Students waiting for the chime to come on. Okay, so here we are. All right, moving on to problem F. Okay, consider the graph of G. Now, they didn't give us that graph. G is the integral of F. On what open intervals from -5 to 5 is G decreasing? So you guys, there's a couple of ways to do this. You can think of this in terms of symbols, and you can think of this in terms of the graph. Okay, now all of us are going to have a different preference on this, but you're going to need to be able to be flexible and look at both of these. Okay, so if you think about this, if we know what G of X is, and they're talking about G decreasing, well, that's talking about its derivative. That would be G prime of X is less than 0. G, the derivative is negative. That would make G decrease, okay? But we talked about this earlier. In this context, G prime of X is f of X. So we already said that G prime of X equals f of X. So we need to find places where f of X is less than 0, okay? Now look at the way this question's worded. It says on what open intervals is G decreasing, okay? And so we often use brackets when we're talking about intervals on which a function is decreasing. But in this case, they ask for open intervals. So we need to be careful about that and not give them closed intervals, okay? So basically, all we need to do is find places on the graph where f of X is negative. So look at the graph, all right? F of X is negative, not negative here. It's 0 there, but that's not negative. It's positive here. It's positive until there. The only place where F is negative is between 1, 2, 3, between 4 and 5. That's the only possible places, okay? Now, you could argue that the graph of G is decreasing on the interval from 4 to 5. And that would be an accurate statement. You could use brackets there. But the problem is this question is specifically saying open intervals, and it's not allowing us to use 5, and it's not allowing us to use 4 because it says open intervals. And so we have to say G is decreasing on the interval from 4 to 5. Like so. This looks like coordinates, so that's why I want to be really clear it's an interval, okay? You wouldn't need to spell that out since it asked you for an interval and you're giving an answer as an interval. You wouldn't need to say that's not a point. But I'm teaching you this, and I could see a student being confused about why is he talking about a 0.45. Okay, the other way that you guys need to handle this question is you need to think in terms of the graph, okay? So let's think about this. G is the integral of f. And so let's look at the graph, all right? Let's talk about this. If you're integrating this graph, if this function is positive, you're adding positive area to it. Right here, you're not adding area. So G is momentarily stopped, okay? It has a horizontal tangent line there because its derivative, which is f, is 0 there. So that makes sense. Then this function G is increasing again because we have more and more rectangles areas. Think of a Riemann sum. We have more and more rectangles areas making G bigger. This area goes up. And here, this area is still increasing because f is positive. So all of these areas are going to continue to add positive to G. But once we get here, once we get to 4, the problem now is every one of these rectangles, because it's below the x-axis, each one of these is going to take away area from G, making G decrease. So graphically, the way you need to look at this is you need to say, well, wait a minute, where is the graph of f beneath the x-axis? Because those areas would be negative. And of course, we'd arrive at the same conclusion. We would say, well, this function f is below the x-axis between 4 and 5. And so if you think of it in terms of integrals and so on, you end up with the same answer. It's just a different approach of how you look at things. Okay, back to the graph of G. On what open intervals, so once again, we need to give an answer with open intervals in it, okay? And it says intervals, so I'm assuming there's more than one. Sometimes they put that in parentheses, so it's kind of up to you. Is G both increasing and concave down? So let's think about this. For G to be increasing, we need G prime of X to be greater than 0, That's the first order of business, okay? And we've already established that g prime of x is f of x. So what we're saying is f of x has to be greater than 0, or graphically, that means it has to be above the x-axis, okay? So f is above the x-axis. So that's our first condition. We have to look for places where f is above the x-axis. So if you look at the graph, that would be everywhere here from -5 to -2. Now, at -2, it's not above the x-axis, and it did ask for open intervals, so we make sure we don't include -2 as part of our answer. Okay, this is also above the x-axis, and this set stretch here is also above the x-axis. And so we need to limit our focus to these 3 segments here, stopping there. Okay? The second condition they gave us is that they said the function g is concave down. So that means that g double prime of x has to be less than 0. Well, where are we going to get g double prime of x from? Well, g prime of x equals f of x. So by definition, the second derivative of g of x would be f prime of x. So what we're saying here equivalently is we're saying f prime of x is less than 0. Well, think about what that symbol means. It's saying the derivative of f is less than 0. So the tangent line to function f has to have a negative slope, okay? So let's look at graph f here. Look at the graph of f, okay? Where is the graph of f? Where does it have a negative slope tangent line? Well, that's between here and between here and here, okay? So we need to look at those areas. We need to look at those sections of the graph where f is above the x-axis, but the derivative of f is negative, okay? So you have to have both of those ideas in your head at the same time. Where is f above the x-axis and f prime is negative, okay? Well, along this stretch here, this function f is above the x-axis, and it has a negative derivative. The slope of this line is negative. The next place it occurs is between 2 and 4. We have f above this x-axis, but it has a negative derivative. So the first open interval goes from -5 to -2, and the second open interval goes from 2 to 4. So before I forget that, I want to write that down. The first open interval is -5 to -2, and the second one is from 2 to 4. So these are the 2 intervals over which g is increasing and concave down. So there we have it. Okay, this next one, h, this is a very popular test item. You'll be expected to handle this. This is basically a chain rule problem, okay? We take the derivative of the baby and we take the derivative of the mama and multiply it by the derivative of the baby, okay? So this is find the slope of the line tangent to h at the point where x equals 1. And so basically what that means is it's asking us to find h prime of 1. The slope of the line tangent to this function h at x equals 1 is literally h prime of 1. So first, we need to calculate h prime of x. So by definition, if h of x is equal to f of something, that would be f prime of, leave the baby alone, 3x minus natural log of x. But you need to use the chain rule because this does not say x here. This is a function of x. So we have to do the derivative of this function. Well, the derivative of that is 3, and the derivative of this, put the negative in there. It's a constant, -1 over x. And so there we have it, okay? So now it's just a matter of evaluating f using these numbers, okay? So we have a rule for h prime of x. So h prime of 1 must be equal to f prime of 3 times 1 minus the natural log of 1 times 3 minus 1 over 1. So I'm just doing algebra now. I'm just substituting in the numbers, okay? So that would be f prime at 3 times 1 is 3. Okay, natural log of 1. The natural log of 1 means log base e of 1. And what that means is e to what power equals 1. That's what a logarithm is, okay? And so the answer to that is, well, that would be e to the 0. So the natural log of 1 is 0. And then 3 minus 1 is 2. So we end up with, I'm going to put the 2 in front. This would be 2 times f prime of 3. Okay? So now it's just a matter of following the rules of calculus. What does f prime of 3 mean? That means the derivative of f at 3. Well, fortunately for us, they gave us the derivative of, they gave us the graph of f. And so we just need to calculate f prime at 3. Well, this is just a line segment. Anywhere here, 1, 2, 3. So we want the derivative at that point there. Well, that's the slope of this line here. And so f prime of 3 would be rise over run. So I'll just do the difference in the y's. 2 minus negative 1 over 2 minus 5. So I'm subtracting the y's. 2 minus negative 1 over 2 minus 5. And that would be 3 over negative 3 or negative 1. So just borrowing from that, the slope of this line segment is negative 1. Let's see, you go down 1 over 1, down 1 over 1, down 1 over 1. That makes sense. The slope of that line is negative 1. And so this would be 2 times negative 1 or negative 2. Okay, did it ask for the equation or just the slope? It just asked for the slope, okay? And so there's my answer. That's the slope, okay? All right, you guys, I feel like I'm on a roll. I don't think I made a mistake on this video, so I will catch you at the next video. Hopefully, that'll be the last video that I shoot for this, okay? All right, you guys, take care.